Is my screen visible, ma?
Yes, sir.
Okay. So let me take this particular problem. So this is the error graph or error which has been occurred in a particular process. Okay. So in this error graph, actually we can see that the error is initially at a value of 0, and when the time progresses after t greater than 0, what happens means it increases to a particular value or to a magnitude of 1 in between the interval 0 to 1. Okay, and after that, between the time interval 1 to 3, it has been maintained as a constant 1 for a magnitude of value equal to 1, and from 3 to 5 seconds it keeps on decreases to a value of again equal to 0. Okay, so as we have discussed in the previous classes, we can divide this error region into four categories. One, between the time interval 0 to 1, that is first region, and from 1 to 3 it can be said as the second region, and from 3 to 5 interval we can take it as the third region, and after 5 we can actually consider it as a fourth region. Okay, now let us take this same error graph and try it for a PID controller. So here actually the problem has been given us. Let us combine everything. Everything means all the three modes which we have discussed it so far. That is P mode, I mode, and D mode, and see how the error of this particular figure produces an output in the three mode controller. And this PID three mode controller is nothing but the PID controller. And this PID controller is having the gains as Kp, that is proportional gain as 5, and integral gain is equal to 0.7 seconds inverse, and derivative gain as equal to 0.5 seconds. And the Pi of 0 value has been given as 20 percentage. That is, when the error is equal to 0, initially the controller output is equal to 20 percentage. That's the meaning for this Pi of 0 means. And draw a plot of the controller output. Okay, so now let us take the now let us split the regions. Okay, so let us take the first region. So we can make a note also. We can take a pen and paper, and we can just note it down step by step while I'm solving also. Okay. So what is the first region? So region 1 is, it's between the interval called 0 less than t less than 1. That is the first interval. Okay, so in this first interval, what is the error value? So here actually error 1 is equal to how much? It is equal to t. Why it is called t? Because the error is an increasing error. So the signal can be actually represented by means of your ramp signal called as t, and the magnitude is 1. Okay, so here actually we have to put it, we can put it as 1t. So since it is actually equal to 1, I'm just putting it as simply as t, because that value is called as the slope value. That is the change in y-axis divided by change in x-axis. Here actually both the change in x-axis as well as the change in y-axis both are equal to 1. So we have just to put it as equal to 1. Okay. Then coming to the region 2. What is region 2? So region 2 can be taken between 1 to 3. Okay, so in this particular region, let us call the error value in this particular region as E2 is equal to 1, because the error is constant there. Okay, so E2 is equal to 1. Then what about the third region? So third region is, so this one is second. So the third region is between 3 to 5. So 3 less than or equal to t less than or equal to 5. So in this region, what's the error value? So error value is equal to E3 is equal to how much? So it is also a ramp signal, but it is a decreasing ramp. So since it is a decreasing ramp, we have to put the sign as minus first of all. Okay, so minus. Next, for ramp signal, we have to put the simple signal as T. Okay, next வந்து பார்த்தீங்கன்னா what is the uh, how much is the slope value? So slope is dy by dx. So what is the change in y-axis? So the change which happened in the y-axis is it is equal to 1, and the change which happened in the x-axis is it is equal to 2. Okay, so if the slope representation is dy by dx, so 1 by 2 it is equal to 0.5. Okay, so we have to put the slope, whether is magnitude of this particular ramp as 0.5t, minus 0.5t. And in the last class itself I have told you, so if you substitute this particular interval, okay, 3 and 5 in this particular t value, so if you substitute and see, you must get the value, error value as that particular value which is shown in the graph. Okay, now if you substitute the value 3 here, what will it becomes? It becomes minus 0.5 into 3 is equal to minus 1.5. So at time t is equal to 3, it shows that E3 is equal to minus 1.5. But in the graph, we are having at a time t is equal to 3, our value is equal to 1. Okay, but actually here we are getting it as minus 1.5. So to make this particular correction, what we are going to do is we are going to add a correction factor of 2.5 here. Now if you substitute the value to t equal to 3 means minus 1.5 plus 2.5 is equal to 1. And also you can substitute the other interval value also. That is other value of the interval. That is the other value of the interval means it is equal to 5. Suppose if you substitute t is equal to 5 means then E3 is equal to minus 0.5 into 5, which is equal to minus 2.5. So minus 2.5 plus 2.5 will be equal to 0. That is at time t is equal to 5, E3 is equal to 0. So it is exactly matches with the value which is represented in the graph. Okay, so what you have to do is, so you have to add this particular correction factor called 2.5. So you should not forget this. Okay, so this 2.5 has to be added with the error value as the correction factor. Next, what is the fourth region which we have discussed about? The fourth region is the, what is the fourth region? Fourth region is t greater than 5. So that can be actually taken as the fifth region. So that is actually we are taking it for our understanding what happens after the time t greater than 5. Okay, so in that particular interval, that is the interval, or after that particular time period, your E4 is equal to how much? It is equal to 0. Now let us find out the controller output values. Okay, so how can we find out the controller output values? So let me take any equation, suppose. So let me just copy this particular equation. So this is the PI controller representation. So here actually I have to add one more thing, that is d by of dt. We have to add it here. So d into So d into EP divided by dp. Okay, and before that we have to have these kp value and kd value. So this is d. So this equation shows your PID controller equation. So P is the controller output, then Kp into Ep is the proportional mode equation, then Kp into Ka integral 0 to T into Ep dt plus Kp into Kd d by dt of Ep plus Pi of 0. It represents the d derivative. Okay, so Pi and d, and in the final we are having the Pi of 0 value. Now let us find out the controller output for each and every region. Okay, so first of all, let us take the P1 of T. Okay, so since we are going to find out the controller output for the first region, so let me take it as 1. So P1 is equal to, okay, so P1 is equal to, what is the Kp value? So Kp value here it has been given as equal to 5. And what is the EP value? So 5 into how much? Here actually the EP value, that is the error value, first here it has been taken as 1. Okay, or else actually we can say take this particular same equation and write it one more time. Okay, so control C, write it one more time for your understanding. That is P1 is equal to Kp into this particular thing will become E1. Okay, so likewise only you have to repeat it for all the other things. Okay, Kp into Ka integral 0 to T, and here actually we are going to write it as E1. Okay, E1 into dt plus Kp into Kd into Kd d by dt of Ep E1 plus Pi of 0. Now we are going to substitute all the values in this above equation. Okay, so P1 is equal to 5 into E1 is what T. Okay, next plus Kp into Ka. What is Kp into Ka? So if you multiply Kp is equal to 5 and Ka is equal to 0.7, we will be getting as 3.5. Okay, so let me directly write this particular equation. So 3.5. Okay, integral, okay, 3.5 or else let me, how can I do this? Okay, so 3.5 integral 0 to T. Okay, so we should not take it as a 0 to 1. Okay, at the end value we should take it as T only, because actually we need to find out that particular value. Okay, so instead of taking the intervals as 0 to 1 and 1 to 3 and 3 to 5, so while calculating the controller output, what we are going to substitute is, we are going to substitute it as, for the first interval 0 to 1 as 0 to T. Then when finding out the controller output 2, for the interval 1 to 3, I am going to substitute the interval as 1 to T. Likewise, for the third controller output, for the interval 3 to 5, I am going to substitute the interval as not as 3 to 5, but as 3 to T. Okay, now for the 0 to 1, I'm going to substitute as 0 to T. Okay, and here actually the value is t plus, okay, it's somewhat difficult to find for type the equation, but for your understanding I'm just going to try it. Okay, so next kp into kd, so 5 into 0.5 is, it is equal to 2.5, it is equal to 2.5. Okay, so 2.5, then again we have to include the derivative. Okay, so let this become 2.5 into d. Okay, what is E1 value? It is t. Okay, so dt divided by dt again. Okay, so dt divided by dt, because this E1 value is t, so d by dt of t. Okay, plus what is our pi of 0? So the pi of 0 is equal to 20. Okay, you can understand how we am just substituting the values. Okay, now this equation becomes, how it will becomes, so p1 again, so p1 is equal to 5p, sorry, 5p plus, you integrate this particular equation, what, how it becomes, so 3.5 1 minute. Okay, so I'm just putting the interval values in the side. Okay, so this particular equation becomes t square by 2. Okay, so this becomes t square divided by 2. Okay, t square divided by 2, and we are having the intervals as 0 to t. We are having the intervals as 0 comma t as the interval. So plus 2.5 d by dt of t is, it is equal to 2.5 only. So 2.5 plus 20. Okay, now if you substitute the values, there is p and 0 in this particular thing. So let us take this as upper interval as t here, and lower limit as 0 here. Okay. So t, if you substitute t and 0 in this particular thing, this particular equation becomes how? So it becomes p1 is equal to 5p 5p plus, so this first, when you substitute this equation as a t, it becomes a t square by 2 only. Okay, so 3.5 t square by 2 minus If you substitute 0 instead of t, the equation becomes 0. Okay, so this particular thing will be the same only. Okay, 3.5 t square by t only, again it will be here, plus 2.5 in plus 20. Okay, the same equation only will be repeated. Okay, so for better understanding, we will just copy it again and write it one more time. Okay, so now we have applied the limits. Okay, after applying the limits, it becomes t square by 2. Now we have to find out the controller output of P1 at two that is interval values. Okay, so this particular controller output uh, has to be found out for the values P1 of 0 as well as P1 of 1. Okay, so first let me find out for P1 of 1. Okay, P1 of 1 means we have to substitute P is equal to 1. So at that time, what will become the value? So 5 into t, it will become 5 plus 3.5 into 1 by 2. If you substitute all those values, the final value will be equal to 22.5 percentage. Okay, 22.5 percentage. What is the next value we have to find out? So the next value we need to find out as P1 at the time of, sorry, first we have to substitute 0. Okay, first time we have to substitute 0. Suppose when you substitute 0, the first two terms gets cancelled. So we will be getting P1 of 0 as 22.5. And when you substitute P1 of t is equal to 1, we will be getting P1 of 1 is equal to 29.25. Okay, so 29.25 percentage. Okay, so these are the two controller outputs. 1 minute. So these are the two controller outputs for the first thing. Okay, next we need to repeat the procedure for the interval 2. So then what we have to do? So Control C. So we have to repeat the procedure for now for the second region. So second region means Kp into 2. That's E2 Kp into Ka integral. Now the integral value becomes 1 to P. Okay. Likewise, here also it is E2 into dt, Kp into Kd, d by dt of E2 plus Pi of 0. Okay. Now P2 is equal to what is Kp? Kp value is 5 and E2 is equal to 1. Okay. Since actually we are having the E2 value is equal to 1. So 5 into E2, 5 into 1, it becomes 1 plus Kp into Ka. What is Kp into Ka value? So Kp 5, Ki 0.7. So it becomes 3.5. So 3.5. Okay, 3.5 integral 3.5 integral so 1 to t here actually E2 value is 1 into dt plus what is your Kp into Kd? So Kp is 5 and Kd is 0.5. So it is equal to 2.5 into d by dt of how much? So d by dt of here actually dt values it is equal to 1. Okay, it is equal to 1. Okay, d by dt of 1 plus what is Pi of 0 value here? From the last class itself I have told you. So this particular value, whenever integral portion comes, we have to calculate this Pi of 0 with the previous values integral part value. Okay, so integral part value. So previous pi of 0 on the 20. Okay, now what is the integral portion value here? So this is the p contribution, this is the I contribution, and this is the d contribution. Okay, so now this particular 20 has to be added with the integral portion value. So integral portion value is this 3.5 into t square by 2. So inge வந்து பாத்தீங்கன்னா நீங்க 1 substitute பண்ணீங்கன்னா என்ன ஆகும்? 1 by 2 equal to 0.5. So 0.5 into 3.5, it will be equal to how much? 0.5 into 3.5 is equal to 1.75. So this 1.575 is the contribution of your integral controller in the previous controller output. So this 1.575 has to be added with this 20. Okay, so now it becomes 21.75. How this particular thing comes? So this particular thing comes as pi of 0 value. Okay, so pi of 0 value plus your integral contributed value. Okay, so integral contributed value in P1. Okay, integral contributed value in P1. Okay, pi of 0 plus integral contributed value. So integral contributed value is here 1.75 and this 20. So here actually it has to be written as 21.75. Okay. Now next we will continue with this equation. So P2 is equal to 5 plus what will happen here? So 3.5 integral of 1 is, how can we do this? Integral of 1, there is constant is t. Okay, so integral of constant is t. So 3.5 t, 3.5 t. Then we have to substitute the interval as t comma 1. So t comma 1 interval has to be substituted there. Okay, then what is here? What will happen to here this particular term? So the differentiation of constant is 0 because d by dt of 1 is a constant. So the differentiation of a constant is 0. So that particular entire term will becomes 0. That is the derivative term contribution will becomes 0 plus 21.75. 21.75. Okay. Now if you substitute the t and 1 value here, what will happen? So this particular equation becomes P2 is equal to 5 plus 3.5 into t minus 1 plus 21.75. Now what we have to do? Now as usual we have to find out the controller output value for two values. So one is for P2 of 1. So P2 of 1 means what? P2 of 1 is equal to 5 plus 3.5 into 1 minus 1, it becomes 0. Okay, so 1 minus 1, it becomes 0. So that whole term becomes 0. So if it becomes 0 means then 5 plus 21.75, it will be equal to 26.75 percentage. 26.75%. Then what is P2 of 3? P2 of 3, that is the second interval value. So P2 of 3 is equal to, if you substitute 3 in t, it will becomes 3 minus 1 equal to 2. So 3.5 into 2 is equal to 7. 7 plus 5, 12. So 12 has to be added with the 21.75. Then the final equation becomes 33.75. 33.75. Okay, so these are the two values. Now let me go to the third region. Okay. Copy the same equation, Control C, Control L. Now P3 is equal to Kp into E3, Kp into Ka. Here integral value becomes 3 here. Okay, 3 to P, E3 into dt, Kp into Kb, E3 plus Pi of 0. Okay. So now let us substitute the values as usual we have done. So P3, is equal to 5 is the Kp value, that is proportional gain value. So 5 into what is E3 value here? So the error for third region is, it is equal to minus 0.5 t plus 2.5. Okay. So let me just copy this particular value, minus minus 0.5 t plus 2.5 is the error value. Okay. Plus Kp into Ka, Kp is equal to 5 and Ka is equal to 0.5. Sorry, 0.7. So it is equal to 3.5. So 3.5 integral integral 3 to t. Here actually what is the error value? So error value is equal to minus 0.5 t plus 2.5. Okay. So I'm just copying it and pasting it here. So integral 3 to t minus 0.5 t plus 2.5 into dt, correct, plus d by dt of what is the E3 value? Again, we have to substitute this particular value here. So d by dt of minus 0.5 t plus 2.5 plus what is pi of 0? Again, we have to calculate. Okay. So if you calculate 21.75 already here. So this 21.75 has to be added with the integral term contribution. So which is the integral term contribution? So integral term contribution is 3.5 into t minus 1. So substitute the greater value, that is 3. So 3 minus 1 is equal to 2. 2 into 3.5 is equal to 7. So 7 plus 21.75 is 28.75. So that is the pi of 0, new pi of 0, which has to be substituted here. So plus 28.75. Now what we have to do is we have to integrate and differentiate the error value here. So it becomes P3. So P3 is equal to, okay, if you just multiply it with the things which are present here inside, so minus 2.5 t, okay, minus 2.5 t plus 12.5, okay, then again plus 3.5, 3.5, so 3.5. If you just integrate this particular thing, if you integrate, what will happen, ma? So this thing becomes minus 0.1 minute. this thing becomes minus 0.5 t square divided by 2. Okay, so likewise what will happen to the next term? So next term plus 2.5 p. Okay, so this is the integration of this particular value which is present inside the bracket, and I'm going to substitute the interval values. So what is the interval value? T and p. So these are the two interval values. Then plus, so d by dt of minus 0.5, what is the value? So if you differentiate the first term d by dt of minus 0.5 t, it becomes minus 0.5. Okay, so minus 0.5 plus d by dt of 2.5 is 0. Okay, so what will happen to that particular value? So sorry, minus 0.5. Yes, correct. Minus 0.5. Okay, minus 0.5 plus d by dt of 2.5 is 0. Then again plus 28.75. 8.75. Now you substitute the values. Okay. Before that, I have left one thing. Okay. So what is the value of this Kp into Kd? So Kp into Kd is, Kp value is 5 and Kd value is, it is equal to 0.5. So 5 into 0.5, 2.5 has to be taken here. I left out that particular thing. So 2.5 into this minus 0.5, or how much? So 2.5 into minus 0.5 is 2.5 into 0.5 is 1.25. So minus 1.25 plus 28.7. Okay, Amma. Are you all clear with this? 2.5 the d by dt of differentiation பண்ணோம்னா இந்த term வந்து minus 0.5 மட்டும் கிடைக்கும். அந்த minus 0.5 நான் என்ன பண்றேன்னா 2.5 ஓட multiply பண்ணிக்கிறேன். Okay, next, coming to the next step. So next step வந்து பாத்தீங்கன்னா என்ன பண்ணனும்னா I have to substitute this interval here. Okay, I have to substitute this interval here. So substitute பண்ணீங்கன்னா என்ன கிடைக்கும்? So t substitute பண்ணீங்கன்னு வெச்சுக்கோங்களேன். So there are 3 or 4 steps. I'm just type it, so we don't have much time. So p3 is equal to what we will get. So p3 is equal to minus 2.55t. Okay, minus 2.5t plus 12.5 plus, okay, plus 3.5 open bracket so in the open bracket, so if you substitute first t substitute பண்ணீங்கன்னா என்ன கிடைக்கும்? அதே தான் கிடைக்கும். ஓகேவா? So the same value we will be getting it here again. So minus 0.5t square. Okay, minus 0.5t square divided by 2. Okay, then plus if you substitute t instead of t, again you will be getting the same term only. So 2.5t plus what will happen when you substitute the other value equal 3. So 3 வந்து பாத்தீங்கன்னா t க்கு பதிலா substitute பண்ணீங்கன்னா 3 square becomes 9. Okay, so 0.5 into 9 divided by 2, if you do that, you will be getting the value as 2.25. Okay, so minus into minus, that becomes plus here. Okay, so minus of that particular interval value. So since we are having the first term value as minus into minus, it becomes plus. So plus 2.25, and here it becomes minus. And if you substitute t instead of this particular 3 instead of this particular t, it becomes 2.5 into 3, it becomes 7.5. So this is the value which you will be getting, 7.5 minus, and in the outer side we are having again minus 1.25, minus 1.25 plus 28.75. Okay, are you all clear with this step? I hope you are all clear till this particular step. Then again, if you simplify this particular thing, P3 is equal to, I'm just writing the values. So P3 is equal to minus 2.5 P plus 12.5. Okay, 12.5 minus. Okay, I'm just going to now multiply the 3.5 with all the 4 terms which are present inside the bracket. Okay, if you do that particular thing, it becomes 0.875 t square. Okay, so t square. So t square plus 3.5 into 2.5, it becomes 8.75 p minus 18.375. Okay, when you multiply those things, minus 1.25 plus 28.75 வந்து நீங்க calculate பண்ணிட்டு, if you multiply that particular term with the 3.5, you will be getting minus 18.375. Okay, minus 18.375 minus 1, well, bracket level minus 1.25 plus 28.75. Okay, I hope it will not be confusing you. Okay, are you all clear? Okay, now let us write this equation as a single equation. So P3 is equal to, there's a group பண்ணுங்க, t square இருந்துச்சுன்னா என்ன பண்ணுங்க, எல்லாத்தையும் group பண்ணீங்கன்னு வச்சுக்கோங்களேன். So if you group it, first let me write the t square term. So minus 0.875 t square, இந்த வேல்யூ இருக்குங்களா? So minus 0.5 t square, அது அப்படியே எடுத்து என்ன பண்ணுவோம், ஃபர்ஸ்ட் எழுதிடுவோம். Okay, next we are having 2 t terms, 8.75 t அப்புறம் 2 minus 2.5 t ரெண்டு இருக்குது. ஸோ அதை எடுத்து சிம்பிளிஃபை பண்ணிங்கன்னா you will be getting it as 6.25 t plus, if you summarize all the constant values, என்னெல்லாம் constant இருக்குது, minus 1.25 minus 18.375 plus 28.75. So if you do all the constant values calculation, you will be getting 21.625. Okay, this is the final thing. Now we have to calculate the third controller output for the two values, that is P3 of 3. So P3 of 3 substitute panningna, you will be getting the value as 32.5%. Okay, similarly, you have to find out the controller output for the next interval value, that is P3 of 5. So P3 of 5 substitute panningna, you will be getting the value as 31%. Okay, you substitute and find out. Okay, so this is P3 of 3 and this is P3 of 5. Okay, then the last one. So last one and then the last one is simple. So last P4 is equal to, so P4 is equal to Kp into E4, Kp into Ki, so integral 5 to t. Okay, so 5 to t, 4, then here also E4, here you have 0. Okay, E4 value என்னது actually? So E4 வந்து பாத்தீங்கன்னா we have defined it as equal to 0. ஓகேவா? ஸோ இப்போ E4 ஜீரோன்னு வச்சுக்கோங்களேன், என்னென்ன டேர்ம்ஸ்லாம் ஜீரோ ஆயிரும். ஸோ எல்லா டேர்ம் வந்து என்ன ஆகுனா ஜீரோ ஆயிரும். ஸோ P4 இஸ் ஈக்குவல் டு, ஓகே, ஸோ P4 இஸ் ஈக்குவல் டு பார்த்தீங்கன்னா Kp into E4 it becomes 0. Okay, plus Kp into Ka integral 5 to T E4 அங்கேயும் ஜீரோங்கிறப்போ வந்து பார்த்தீங்கன்னா integral term also becomes 0. Then Kp into Kd into d by dt of E4 அதுவும் ஜீரோங்கிறதுனால derivative term will also be equal to 0. Now we have to calculate the Pi of 0 also. Pi of 0 no. So Pi of 0 value வந்து பார்த்தீங்கன்னா previously it is equal to 28.75. ஸோ இந்த 28.75ல இன்டெக்ரல் டேர்மோட கான்ட்ரிபியூஷனை நீங்கள் என்ன பண்ணணும், கால்குலேட் பண்ணணும். ஸோ இன்டெக்ரல் டேர்மோட கான்ட்ரிபியூஷனை வந்து பார்த்தீங்கன்னா 5 சப்ஸ்டியூட் பண்ணி இதில் நீங்கள் இந்த இதில் கால்குலேட் பண்ணீங்கன்னா, ஓகே, இந்த போர்ஷனில் இஃப் யூ கால்குலேட் திஸ் பர்டிகுலர் டேர்ம் பை மீன்ஸ் ஆஃப் சப்ஸ்டியூட்டிங் t is equal to 5, then you will be getting the value as 32 here. ஓகேவா? ஸோ 32 28.75 ப்ளஸ் ஒரு எவ்வளோ ஆட் பண்ணணும், இன்டெக்ரல் டேர்மோட வேல்யூ வந்து பார்த்தீங்கன்னா 28.75 மைனஸ் பண்ணோம்னா 3.25 வரும். ஸோ அந்த 3.25 வந்து பார்த்தீங்கன்னா 28.75 ஆட் பண்ணும் பொழுது யூ வில் பி கெட்டிங் இட் ஆஸ் 32. ஸோ யுவர் P4 வேல்யூ இஸ் ஈக்குவல் டு, P4 is equal to 32%. ஓகேவா? இங்கே வந்து நமக்கு T வேல்யூலாம் ரெண்டு இன்டர்வல் கிடையாது. ஸோ ஆஃப்டர் T we are going to find out the controller output that is equal to as 32%. Okay, ma. So now what are all the values we have calculated so far? So far we have calculated the controller output for all the regions. Okay, all the 4 regions. Okay, ma. So இப்போ இதை மட்டும் நம்ம என்ன பண்ணுவோம், எடுத்துட்டு போய் இந்த இடத்துல சப்ஸ்டியூட் பண்ணுவோம். ஓகேவா? ஸோ இப்போ இந்த இடத்துல let me copy this and put it in a paint. Okay, so let me project this particular அப்படியே ப்ரொஜெக்ட் பண்ணிக்குவோம். Okay, so let this be the T in seconds. Okay, seconds, and let this be the controller output. So it is equal to P of T controller output. Now what are all the values? So first let me copy down all the values there. So P, you open a text box. Next, then the third region controller output is, then the last region controller output is equal to 32%. Okay, these are all the obtained controller outputs. Now we are going to just substitute the value. So now we know that the Pi of 0 values initially it is equal to 20. Okay, so how can we do that? So let this be equal to 20 first of all. Okay. Then let it be 22, sorry, 22, then let this be 24. Okay, then let this be 26. So what is the maximum controller output? It is got up to 34. Okay, so let this be 28. Let this be 30. Let this be 32. And the maximum controller output be 34. So these are all the controller outputs. Now what is the PI of 0? So PI of 0, we know that PI of 0 is equal to, initially it is equal to 20%. Okay. So now we have to start from that only. So first initially it is equal to 20%. Okay. And what is the PI of 0 value at 22 point, PI of 0 in the first controller output? It is equal to 22.5. So in the 0 itself, what happens? It has jumped from 20 to 22.5. So that is the action of your derivative controller. That is what actually we have discussed in the last class. So from 20 to 22.5, it has been jumped in the 0 itself. Right? So from 0 to 20 to 22.5. Okay, and at a time t is equal to 1, it has been moved to 29.5. So 29.25, somewhat actually it will be like here. Okay, so it goes to 29.25 here. Then at p2 of 1, so let this be 1, then 3, then 5. Okay, so what happens when p1 of 1, so p1 of 1 like becomes at 29.25. And what happens when the controller output switches to this particular value? So it reduces to 26.75 in the same time period. There is a time t is equal to 1 itself. It has been reduced from 29.25 to 26.75 somewhat here because of the derivative action. Okay, and from that it has been constantly where it goes. P2 of 3 is, so P2 of 3 is 33.75. So from there it goes to 33.75. 33.75 is somewhat here. So it goes to 33.75, and there it has been reduced to 32.5. 33.75 to it has been reduced to 32.5, and at 5 it comes to 31. Okay, 32.52 becomes 31, and again at p4 it has been go to 32, and it is maintained as a constant value there. Okay, so this is how actually you have to draw the controller output. Okay, so here all these sudden jump and all here, no, so these are all actually due to the action of your derivative controller. So this is the action of derivative controller, this is the action of your derivative controller, this is the action of your derivative, this is the action of derivative. Okay, and this is the combined action of your pi. Okay, this is the action of your p and I. Okay, so this is the action of pi, and here this is the action of your pi. Okay, can you understand? So this is how you have to um, what you have to plot the controller output for a given error graph. Okay, so I hope everyone has understood it clearly. If you have any doubts, you can ask me.